Alright, boys and girls, welcome back to the drive-thru for a special, just relaxing Thursday. No jokes today. Look, there's 6 graphing questions on this worksheet. It's really not that bad. I want to explain to you what's going on with these. Then I will help you with the best, I think, process to doing these. So, I'll have to pause the video every once in a while. I want you to look at these 2 equations in number 1, and I want you to think hard about what we've been learning, okay? This is an exponential equation. This is a log equation, okay? So I'm going to get a new screen. I'm going to rewrite those. Y equals 2 to the x, and y equals log base 2 of x. Okay. No. So we got y equals 2 to the x, and y equals log base 2 of x. Is that what it says? Okay, now I want you to remember the change of base formula, okay, that we learned yesterday and the day before. What thing in this equation is the base? 2. So you could also consider that 2 to the y equals x. So now what I want you to understand is that these 2 things are inverses. Do you remember when we were solving for inverses last chapter? You would switch the y and the x and then solve it for y. Do you remember that? So now we are relating something we learned last chapter to something we're learning now, which is exactly how it's supposed to work. Well, if you remember the other inverse questions, you had these tables that were like something like that. I'm just making up numbers. How would you write down the inverse of this table? That's right. You would just switch the values for everything. Switch the places. Do you remember that? So if you can remember all of that, here's what I want you to understand about today's lesson. This worksheet, every single function, this is an exponential equation, this is the inverse, okay? Exponential, inverse. Exponential, inverse. So we're just going to take a look at a random one that's not super easy but not super hard. So we'll go with number 4. And hold on, let me pause. Okay, so we're back. We're on number 4. And here I'm going to now tell you the strategy for these. I could teach you how to put this in your calculator, but it's really quite difficult and not that necessary. Very rarely will you ever be asked to graph logs. The point of logs is that they get rid of exponential functions. So what this worksheet is trying to show you is that indeed these are inverses. So I think the easiest way to do it is to just put this in your calculator, because we're very good at this by now. So y equals, I'll just type it in exactly how they have it, 3/4 to the x power, okay? Graph it just so I have an idea what it's going to look like. Okay, so it's going to gradually go from high to low. It has an asymptote. And then I just go to my table. And notice that most of these points are kind of annoying, but it's okay. I've been writing down 5 points just because I want to make sure I get the graph right. So here's the ones that I'm going to pick. -5, 4.2. Sorry if I'm in your way. And then I'll do -3. I'm just going to skip around a little bit so I give myself some space. 2.3. -1, 1.3. I got to get my y-intercept right, so that's 0, 1, and 1, 0.75, okay? Eventually, when you start working on your homework here, it might be to your advantage to have a pen and a pencil, or 2 different colored pens, so you can keep these straight. All right, so look, -5, 4.2, just get it close. -3, 2.3. -1, 1.3. 0, 1, 1.75. So I just remember what it looked like. That's good. My dots look like the graph on my graphing calculator. And so I'm just going to try to imagine this arc. And it's going to keep going and getting closer. And I am so proud of my first graph. That's as good as I could do. Okay? The domain of that thing, well look, I can put in any x value I want that's negative. I can put in any x value I want that's positive. So once again, my domain is all reals. And what do you notice about the range? Well, the range is the y values. What do you notice about the y values? It's got to be bigger than 0. Excellent. Okay? So far it seems like, well, this is nothing new. This is nice. It is actually nothing new. Okay? Okay, so now, here's where the strategy comes in. I could teach you how to type this in your calculator and graph it. I think that is completely a waste of time, because we already know that they're inverses, and we know how to handle inverse functions. What do? You just make your x's into y's, right? So -5, -3, -1, 0, and 1. And then you make your y's into x's. 4.2, 2.3, 1.3, 1, and 0.75. And now I'm just going to sketch those. So 4.2, comma -5, 2.3, comma -3, 1.3, comma -1, 1, comma 0, and 0.75, comma 1. Okay? So now you have to imagine that, if you remember, these are symmetric to this diagonal line that runs corner to corner in your graph. That's how inverses work. So now what's going on is this is the asymptote. And can you see how those graphs are kind of like cool little mirror images of each other? That's what you want on every single question on the homework. You want them to mirror over this diagonal line right there. Okay? Now I'm going to undo that so I don't confuse you guys and make you think that that diagonal line is part of the graph, because it's not. Okay? So now we got one more thing to talk about, and then I'll be done with the vid. Look, now it looks like our y's can be whatever we want, right? So maybe you would expect that all you do is switch these, just like you do the numbers, but be careful. This is no longer y is greater than 0 here. What is it? Take a look at the red graph. What's always positive? X is now always bigger than 0, and that should make sense because your domain is your x's and your range is your y's, okay? And before I finish, I just want to apologize for saying vid in this video. I promise I'll never, ever, ever do that again. Boom!